Hi, good morning, and welcome to the ZP FoodSense webinar. So we like to do this webinar once a week, and it's really answering questions that have come in during the week. So I will talk rather fast, and there's lots of slides to go through. So today's the 29th of November. We tend to do this at about 8 a.m. London time, though we tend to go early as well. And it's recorded, so we don't expect people to necessarily have to come here live, because we appreciate some of you are in, for example, California, etc. But I will talk about FoodSense. Just to know that FoodSense Generation 4, it is, if you become a user of the Generation 4, you do get personalized online training. That definitely happens. We have laboratories, we demonstrate, you demonstrate back to us. We make sure that everyone's using the device correctly. We do have weekly webinars. So we've had a couple of questions in this week about how to measure low Scoville heat unit ratings, of like 100 Scoville heat units. And also a complexity of how to blend chilies together, so you can have a range of like 1 to 10 or 1 to 10 bands with different Scoville heat units in each band. But I will come to that in a minute. Also, there's the monthly webinar. So if you're interested in seeing, rather than just talk as I am doing now, we do also do live streaming demos as well. Those are quite effective because they show you how quick and easy this is to do. And it shows you that, we can, the technology is robust and we can do it in real time. Just to say, if you're a G4 customer, it's really easy to help you. I will talk about the fact is that I have Generation 4 customers in India, for example. In fact, some of the data, two of the data today, one maybe from Japan. Oh, actually, one's from China, one's from India. And we're able to support them so easily because they're what's called Generation 4. Which basically means that their data is streaming to the cloud. They shared it with me and I'm able to look at it in real time as well. As I say, there's weekly webinars. This is the weekly webinar. There's personalized training once you're a user. And then there's also a monthly webinar and live streaming demo. The next one's on the 14th of December. I'll make sure that I put the link down below when we've finished. The next thing to say is, we've got two questions today. One person wants to measure mild chili, 100 Scoville heat units. I'll touch upon that. And the other person wants to sort of accurately, I should say precisely grade chili products from 1 to 10. I'm not going to talk about the difference between accuracy and precision today, but they want to precisely have them ranked, so that's okay. Question number 2, as I say, is a bit more to this question. They want to grade 1 to 10, and they've really touched upon the fact that this is something we talk about a lot in the webinars, that they get these certificates of analysis, and they're not reliable. And they're not reliable I really think from a sampling perspective, and I will talk about heterogeneous samples in a minute. Things like chili powders, chilies, chili powders, and even chunky chili sauces are very heterogeneous. So if you just go in there, take a sample, get a reading, great. But it doesn't mean that that sample is representative of the rest of that material. And I will demonstrate that today with a chili powder example. So they do want to have precise ranking of their chilies from 1 to 10, or their chili powders from 1 to 10. So, and I will discuss the overall system today as well. So 2 questions to cover. So question number 1, just out of interest, when somebody said to me, we want to detect 100 Scoville heat units, I did do a little bit of a test here, just to kind of see what 100 Scoville heat units actually tasted like. Because we do quite a lot of testing, and Tabasco sauce, by the way, is a very homogeneous sample. It's probably, in terms of blended, it's extremely blended. So, what comes out there is quite runny and thin, and it is homogeneous. So anyway, that aside, it's a homogeneous sample. I did make up 100 Scoville heat unit sample just to taste test it. And I agree, you can actually taste it. I was thinking, God, is it so dilute that you can't actually taste it? But actually you can taste it. So the thing about the way we work at ZP is the product is very non-toxic. Now what I mean by that is, if you ever go to an analytical lab where they have an HPLC system, you will see that actually they're using organic solvents. And these organic solvents, you can't have them near your food products. And also it's hard to ship organic solvents. They're flammable, they're toxic. When you've used them, you've got to dispose of them. They're a real pain. But with the FoodSense technology, the liquids that we give you are actually just water-based, and they're innocuous or inert. Now, the reason we do this is if you look at the solubility of capsaicin, so obviously the molecule that gives you the hotness of chilies, it's actually got a solubility in just water of about 500 Scoville heat units. So if you leave it mixing or dissolving over time, it'll plateau out about 500 Scoville heat units. And therefore, if somebody's product is naturally 100 Scoville heat units, they're about 1/5 of the saturation of capsaicin. So that's okay. You're not sort of you're not at the absolute concentration. Now, the reason I bring this up is because when you've got a sample of 100 Scoville heat units, I don't think you need to dilute at all. But I have asked them, what is your sample? Because the fact that it might be 100 Scoville heat units is interesting. But the next question then is, what is it? You know, I mean, is it a sauce? Is it a puree? Just tell me in an email, because I have asked you in an email what it is. Now, the reason this is relevant is because most of the time, people are actually trying to measure things of like 5,000 Scoville heat units, 50,000 Scoville heat units, 100,000 Scoville heat units. And in fact, those are exactly the kind of ranges when I think about today's that, you know, often people are actually dealing with. So you can understand that what we're doing is, and if you come to one of our demonstrations, you'll see us do this. That, in fact, I'll just go back slightly. In this video here, they're weighing out the chili powder. So they sort of weigh it out. If you come to one of our live streaming demos, you'll do this. She's just weighing it out now. She's pretty, and then she's getting a liquid out. She's just going to add the liquid to it. So the reason she's doing that is she's, I realize I want to pull myself out of the image of this. The reason that they're doing this is because they know that the capsaicin is not terribly soluble. So they're probably doing what we call a 1 in 100 dilution. They take like 0.1 grams of chili powder and add 10 mils of the buffer here. And the reason that she's doing this is because she's trying to avoid, well, she knows that capsaicin is not terribly soluble. So we have a bit of a rule of thumb. I want to call it the ZP500 rule, which says if you think your sample is 0 to 5,000, do a 1 in 10 dilution. Now these people are actually 1 in 100, so I might actually not do 1 in 10. You would end up doing maybe 1 in 1, maybe 1 in 2, maybe 1 in 3, but not 1 in 10. But for example, one of the mildest things that we routinely test is capsaicin. So there we do a 1 in 10 dilution so that we bring the 5,000 down to 500. If somebody's dealing with a something like a chili powder and it's 50,000, for example, we might tell them to do a 1 in 100 dilution. If it's something that's a lot hotter, like 500,000 Scoville heat units, we might tell them to do a 1 in 1,000 dilution. So we have this kind of rule because if you take 500,000 divide by 1,000, you get to 500. So all the time I try to get to 500. These people are not at 500. They're actually at 100, which suggests a lot less dilution. It may be no dilution at all, depending on what sample type they actually have. And then if you get into the millions, then we're doing quite a lot of dilution. So it's this, if I summarize this, capsaicin is an organic molecule. We want our product to be safe. Therefore, we don't put organic solvents in the kits. Therefore, we run the 500 rule, which says if you think that you're 5,000 Scoville heat units, do a 1 in 10 dilution. If you think you're 50,000 Scoville heat units, do a 1 in 100 dilution. That then means that we're basically bringing them, we're dissolving all the capsaicin, but we're doing it with safe materials or safe solvents, let's say. And if you get stuck, and this is the beautiful thing about the FoodSense Generation 4, and you'll see this in a bit, if somebody gets stuck or wants my advice, even if they're in India or even if they're in China, the data goes to the cloud, they can share it with me. It's their choice to share it, and I can look at it and we can actually, make sure that everything's working okay. What you're going to find out is if you're using certificates of analysis from third-party labs, you have no insight into those numbers. And actually, questioner number 2 in this particular one says, I can't rely on the data I'm getting from my suppliers, and that unreliability, I'll discuss it in this webinar now. So I'm just going to talk about sampling reproducibility versus testing reproducibility, because people do ask me, what's your testing reproducibility? So I will discuss that, because the biggest irreproducibility is actually sample irreproducibility. So sample reproducibility, testing reproducibility. So test reproducibility. So we do have these, question number 2 here referred to them as cartridges. I think I've always called them sensors, but we have these sensors, the chili sensor. Before we ship these chili sensors to you, we do a lot of factory testing, making sure that these sensors are working. So with the HPLC system, what you don't know is that they have to do calibration, but what they don't tell you is how often they do the calibration. So they have to calibrate the HPLC system with known concentrations of capsaicin so they can build up a calibration curve. But those calibration curves, they don't last forever. You have to kind of routinely do this. So sometimes the delay in getting the result is because they need to build up enough samples to justify doing a calibration so that they then can run all the samples from all the different people who've sent the samples in. Now, calibration is not a problem for our technology because we check the manufacturing at our facility to make sure that we've got reproducible manufacturing. It's really important to us. And we make sure that, like, something here is called relative standard deviation, that our relative standard deviation is single digit. So 6%, 5%, 6%, 6%. So if you're asking the question, what's the uncertainty in my result that comes from your sensors, then I would argue it's about 5 or 6%. As long as you're below in life less than 10%, then your analytical system is useful to you. So we're less than 10%. And that makes us calibration free, which means I don't give you the problem. I keep the problem of calibration in our factory. Good. And just real data. You can kind of see here that now I will talk about cyclovoltammetry in some slides down here. This is the kind of patented work that we've done with the University of Oxford. And I will talk about that shortly. But all I want to show you here is this is the raw signal. So we can test at known concentrations. Each color represents a concentration. We can see that we get signal versus concentration. I will come back to this kind of data in a little bit as well. There's one thing to say is it's got a very distinctive fingerprint. So capsaicin is a unique molecule, a very distinctive fingerprint. The shape of the raw data tells me that it's capsaicin, and the area under the curves tells me how much capsaicin is actually in that sample. So I will go forward a little bit more. This is actually customer data where they did 15 tests on the same sample. So they are testing they're testing what I call test variability. I take the same sample, I test it 15 times. They did it both by HPLC and also by FoodSense, and they got a really good correlation between the two. And in fact, sort of a difference of 5%, a difference of 4%, a difference of 3%, a difference of 3%, a difference of 6%, a difference of 3%, a difference of 5%, a difference of 7%, difference of 1%, difference of 2%, difference of 1%, difference of 5%, difference of 5%, difference of 3%, difference of 1%. You shouldn't really average all these out, but in fact, I just did it for fun. And when I averaged it all out, I actually realized that the difference was 0%. So our testing is very reproducible. I say that, we're 5 or 6%. Now, what I want to say then is there's something else called the sample variability. So you've got a powder like a chili powder like this, and this really affects question number 2 as well as question number 1. You've got a chili powder like this, and if you test from here, you'll get one result. If you test from here, you get another result. If you test from here, you get another result. If you test from here, you get another result. If you test from here, you get another result. That's because chili powders are heterogeneous. So this is some microscopy work that I did just a couple of days ago. In fact, I sort of zoomed in, and when you look at it, chili powder is not like all these nice evenly shaped and colored particles. It is actually full of all sorts of shapes and colors of particles. And this is obviously a microscopy or a microscope image of chili powder that I did in the lab. And you can see that it's actually quite variable. And this is the heart of the problem with, I think, sort of the food production of chili products, that people think or not pretend, but they know that actually chili powders are heterogeneous, but we're all treated like they're homogeneous, and they're not homogeneous. They're actually quite heterogeneous. And it really comes from, so if you look for heterogeneous mixtures, then I would say a chili and chili powder are heterogeneous. Tabasco sauce is much more on the scale of homogeneous, but it's much more sort of blended up. The heterogeneousness of it actually starts with a chili, that if you analyze a chili, that you're going to find that most of the hotness is actually in the ovaries it's not evenly distributed out. So when you kind of blend this up, it does help then to sort of blend the ovary with everything else when you sort of dice it and blend it. But most of the hotness is actually in the ovaries. So I suppose you could have very hot ovaries, let's say, and if you've got a large then pepper, you end up sort of distributing those ovaries throughout the rest of the material, and then overall you may actually have you'll have a milder chili powder. But we have done work and analysis on where the hotness is, and it happens to be in the ovaries. I should have put a link to this, but I do have a short on YouTube just describing this data in a little bit more detail. But also I will do it in more detail when we do our monthly webinars. We've also looked at what happens when you actually take a chili and you dry it down. The quick answer is when you dry a chili down, you increase the hotness by about 10x because the water content of a chili is about 90%. So if you take away 90% of the volume, which is due to water, then you end up increasing the hotness by about 10%. And we've definitely done a theoretical calculation and actually done measurements and looked at the difference, and yeah, it works out really well. Just to talk about sample variability. So if you have a heterogeneous sample, let's say a chili, and you sample it in random places, whether you get a capsaicin molecule or two capsaicin molecules depends on where you actually sample from. Now in a powder where you've chopped it up a bit more and the capsaicin is a bit more evenly distributed, if you sample here you get one capsaicin molecule. If you sample here you're touching on about 3 capsaicin molecules. If you touch here you get 2 capsaicin molecules. So understand that the more homogeneous it becomes, then the more, if you randomly take a sample, then it's more likely to be kind of representative of the entire population. But then if you take something like Tabasco sauce, which is very blended, then it doesn't matter too much where you sample from. I've actually done some statistical analysis on this, and I'll do that in the next few slides. But I would describe chilies as very heterogeneous. Chili powders is still heterogeneous, but not as much as a chili. And then, as I say, Tabasco sauces on the other end is very homogeneous relative to the other two. If you sample chilies and you just do it randomly, and I've sort of mocked it up here, then you'll get what's called a relative standard deviation of about 141%, because here I got no capsaicin, here I got no capsaicin, here I got 1 capsaicin, here I got 2 capsaicin. If I do the same kind of mental experiment with a chili powder, here I got 1 capsaicin, here I got about 3, here I got 2, here I got 3. There the relative standard deviation is 43%. So it's still 4 samples, each sample is a bit more representative of the rest of the population. But when you do something that's very, let's say, homogeneous, if I sample here, sample here, sample here, sample here, it doesn't matter. My relative standard deviation is about 13%, which is really kind of getting close now to actually what's happening in practice. You're going to find out that this is what's happening in practice. So here's some data that came in from India, where they had a chili powder. They took 5 samples. And what they did is they took those 5 samples, and the reason they did this is because they were kind of understanding that actually, if you get like I say a sort of a container shipment of chili powder, there's no way that you can take 1 sample from that and measure it and say, oh yeah, there we are, that's the hotness. Doesn't work like that. So they took 5 samples, they made up 5 solutions, they vortexed them and they left them standing overnight because they really wanted to make sure that all the capsaicin was dissolved. So they were very sort of strict about it, which is, good science. And so they got a sample 1, a sample 2, a sample 3, a sample 4, and a sample 5. And then they tested it. And the nice thing is that they tested it, they got the result on their phone, but also because they got the result on their phone, the data also went to the cloud, and so we were actually able to come in and look at their raw data. This is really important for the person who's interested in doing 100 Scoville heat units. We are able to look at your data and just make sure that everything's actually working okay. Because their question was, can I believe these results? And I say, unlike, let's say, HPLC done by an analytical lab, I'm able to show you the raw data. So we were able to look at their raw data on all 5 samples. Even though this was happening in India, all the data was going to the cloud. They chose to share the data with me. That's an important point. And we were able to essentially see their data. So sample 1 had like 55,000 Scoville heat units. Sample 4 had 91,000 Scoville heat units. So you're like, wow, those are very different. But that's not the test. That's not a reflection on the precision or accuracy of the test. It's a reflection on the heterogeneity of the sample. But they did sample 1. They also did a sample 2, a sample 3, their sample 4, and their sample 5. And what's interesting then is these numbers. This is low. This is high, and then the other 3 are actually quite in the middle. And this is what's describing a normal distribution. So you kind of have this low results, middle results, and then it tails off to the high result. That's a normal distribution. So that tells me that their sort of data is not skewed. It tells me the data is good quality. So I was able to do a mean on it. So I took all the 5 samples, did a mean on it, and got a mean of 76,000 Scoville heat units with a standard deviation of 13,000 and I called it here coefficient of variance. I've also used the term relative standard deviation, or RSD. It's just taken standard deviation divided by the mean. I got 18%, which is what they were, they were happy with that then, because what it says there is that their result, they can believe their result and say that the hotness of that chili powder is 76,532 with a plus or minus 18%, but they were happy with that 18%. The more testing they do, by the way, the more essentially the smaller the standard deviation will come, because the more the number of samples drives down the standard deviation. But they only did 5 samples, which is fine. Because I bring it up now, and this is linked to question number 1 and question number 2. Because when you get these certificates of analysis, this is just something I'm using for educational purposes. I just found it as a representation on the internet. What I find interesting is that here's a picture of the sample. They follow what's called the AOAC method. This is great, so this is the HPLC method. They get the results, 11,636, but there's no raw signal. I get it, because that's not what a certificate of analysis is about. There's no indication that when this HPLC system was calibrated, and there's no uncertainty indicated. Those numbers are taken as that must be the number, but you've no idea as to how many samples were taken, how many samples were run, is this the average of all those samples, and therefore what's the standard deviation or uncertainty in that result? You get none of that. You just get an absolute number, and that's what's happening a lot. People get these numbers, they believe them, but actually they don't understand the layers of science actually to get that number, and therefore they just take it on trust. The nice thing about the ZP system and the FoodSense system is you get the raw data, so you kind of you can take the number on trust on your phone, but you can actually also dig into the raw signal as well. I'm not expecting you all to do this, but this is also to help me support people, because then I'm not like, when you just get a number, how do you argue about it? But when you've got the raw signal, then you can actually discuss it a bit more. So the way this technology works is, the sample goes on the FoodSense generation 4, the data goes up to a cloud system called Julie, even though you get the result on your phone there and then. But also, as I say, the raw signal is up in Julie, and then if you choose to share it with us, then you can leverage the power of the ZPT, and we can support you and give you confidence actually in your results. The reason I could talk about this a little bit is this technology came from the Compton lab at the University of Oxford, and it is patent protected, so we do benefit from that. This bit now, I'm dipping a little bit into the science of this a little bit, but we are using an analytical technique called voltammetry. The voltammetry of capsaicin gives us these very distinctive peaks. This is really, I would call it a fingerprint, and we can assign these peaks to actually what's called the oxidation or reduction of capsaicin. So each peak in here means something, and then if we get the right peaks, then the area under the curves tells us how much capsaicin is actually in there. As I say, there's an original paper from the University of Oxford. We licensed it, they patented it, and we now apply it. You can also tell from my tell that we're also very scientifically involved in this product as well. I personally just happen to have a PhD in the background science of this sensor. Question number 2, so really a lot of that was around about saying, question number 1 was really about how do I test a low Scoville heat unit rating of 100 you basically just don't have to dilute as much as I would have otherwise advised people to do. Question number 2, somebody wants to grade their product from 1 to 10. The supplier measurements are unreliable, and I think I sort of covered that a lot in just now about when you get that certificate analysis, you've no idea what the reliability of the result is because you don't have this plus or minus relative standard deviation. But they want to be able to at least, make up that sample 1, or sorry, grade 1 is the mildest and grade 10 is the hottest, so I do understand the question. And you want to understand the overall system. I suppose the overall system, there was quite a lot of detail there about, we do the dilution based on what we think the hotness is. We have a test, let's say reliability of 5 or 6%, but it's the samples that are most heterogeneous. So it's very easy to do Tabasco sauce because the sample is very homogeneous. It's harder to do chilies and it's harder to do chili powders, and therefore you have to do multiple samples. But nobody does multiple samples because HPLC is too expensive until you've got the FoodSense. So this person wants to grade and wants to make up some chili blends or chili powder blends from 1 to 10. I actually did some calculations and sort of said, okay, if you can identify a chili powder that has a 500 Scoville heat unit, and for example, you can identify a chili powder that has a 750,000 Scoville heat unit by blending. So for example, if I blend the chili powders together, then for example, if I want to hit 450,000, then by blending these chili powders together in the ratios, then you can get to all these different heats. So I'm sort of suggesting that you kind of, to get the hottest, it's 100% of the 750,000 Scoville heat unit powder. If you want to get to 500,000, it's about 67% of the 750,000 Scoville heat unit powder blended with 33% of the 500 Scoville heat unit powder. So you can basically see that as we go from top to bottom, we take away obviously the hottest powder and add in more of the milder powder until at the bottom here it's just 100% of the mild powder, which is 500 Scoville heat units. Now to do this, I would say even more accurately, what you end up doing is you end up identifying a very mild powder, a medium powder, and a very hot powder. And so to get the kind of top range, you would end up blending the medium with the hot, and to get the bottom range, you'd end up blending the medium with the mild. That would be my strategy in order to do this in a precise way. And of course, the nice thing is that the powders are actually going to be very variable. So this calculation, which I can do, has to be redone depending on actually what powders you have. I've made up some fictitious powders here, but the calculation could be redone based on what you actually have, and it can become more sophisticated. But in theory, you should be able to do this range by blending a very hot with a very mild. But as you say, your problem is you can't believe the numbers that are coming in from the suppliers because those certificates of analysis are pretty flawed. You have to do your own testing. So in conclusion, if you want to do a mild, like 100 Scoville heat unit product, you don't actually have to necessarily dilute it. But the nice thing is you can run the test, we can look at it, and we can make sure that it's working out properly. When you've got things like chili powders, they're very heterogeneous. And that's where, to really know what the hotness of a chili powder sample is, you have to do multiple testing. Nobody does it because it's too expensive to do by HPLC. So everyone gets personal training. There's a weekly webinar. Here it is. You can see we put a lot of effort into answering questions. And don't forget there's also the monthly webinar on the 14th of December as well. So if you've got any questions, please don't hesitate to reach out to us. Okay, thanks very much.